Hello students. Before we get started, remember that you need to know these 5 formulas for the test, so I would practice them even though I won't be there. So far we know the arithmetic ones and we know the first geometric. Today we're going to learn the sum of the geometric. So that is our learning target today, to find the sum of geometric series, and we'll also use it with sigma notation. Now remember, geometric series is when you multiply from one term to the next. So here is a representation of the sum of a random geometric series. So the sum of n terms would be the first term plus the second term. Remember, the second term is by taking the first term multiplying by some random ratio. The next term would have the ratio twice because you take the first one, multiply ratio twice to get their term, and so on and so forth. And then this is the explicit formula we talked about the other day to get the nth term. We actually go n minus 1. So you don't have to write any of this in your notes. I just want to show you how we actually get the geometric series formula because I think it's kind of interesting. So what I'm going to do first is I'm going to take the entire sum formula, S sub n, and multiply everything by r. So in other words, the first term will be a sub 1 times r. The second term will be a sub 1 times r squared because there's 2 of them now. The third term will be a sub 1 times r cubed because there's 2 here and there's 1 more here. The last term would be a sub 1 times r to the n now because we have n minus 1 plus 1 more. So I have that written right here. That's exactly what I just said. So this is first, second, third, fourth. I try to line it up exactly so these go together, these go together. Now what we're going to do is we're going to take the first line and subtract the second line. Oopsies, where is it? There it is. So first line minus second line. That's all that this says right here. So if you notice, if I subtract the second line, really neat things end up canceling. This crosses out with this, because if I have this minus this, they're gone. 0. Same thing here. Same thing here. All right, so on and so forth. The n minus 1 term would actually go with the one here. I didn't write it in, but it'd be the previous term before the last term. So basically what we're left with is we're left with this term right here, a sub 1, and we're left with this term. These are be the only ones that don't cross out with something else because the other line doesn't have it. So what's left is a sub 1 minus a sub 1 times r to the n. All right. So remember, we're trying to solve for the sum, so we're trying to get s sub n alone. So what I noticed is I could factor out an s sub n from both sides. So take an s sub n out of this term, you're left with 1. Take an s sub n out of this term, you're left with r. And this one, we could factor out, an a sub 1. So take an a sub 1 out, you'd be left with 1. Take an a sub 1 out, you're left with r at the end. Well, like I said, we're trying to get s sub n alone, so the way to factor that out is to divide by 1 minus r on both sides. So our sum formula is right there. This is the sum formula. So I have it on the next slide as well. So if you need the sub to pause the video, that's perfectly fine. This is your geometric series formula. So this is formula number 4 out of the 5 you need to remember. So remember, S sub n is just the sum. A sub 1 is the first term. R is the ratio, the thing you're multiplying by. And n is the number of terms. So if I'm trying to solve for 10 numbers, that means I'm adding 10 different numbers together. I'm going to put 10 in this place of n. Okay. Now, my formula doesn't have parentheses around this 1 minus r, but you'll see in a second that is super important when you're typing it in. So this is not a difficult formula once you plug everything in. The hardest part is actually just typing it in the calculator to make sure your calculator is doing the correct order of operations. So like I said, if you need to pause the video, write this down, please do so. But I'm going to move on now, and we're going to try a bunch of examples. So the first example says, find the sum of 10 terms of the geometric sequence where a sub 1 is this and r is this. All right, so we've done this in class before. What I like to do is I like to list off the things I need. So here are the things I need. Here's the formula. I know I need a sub 1, r, and n. So these are the 3 things I'm going to find. Well, I started off with an easy example because guess what? They gave me everything. A sub 1, 4.56, r, 2.15, and the number of terms, it tells me up here I want 10 terms. So there it is, 10. All right, so once I have my list, I can plug it in. So we are finding the sum of 10 digits, so S sub 10. First we put in a sub 1, so 4.56. Then we go 1 minus r to the n. So 1 minus 2.15 to the 10th. And on the bottom, it's just the 1 minus r. So you look at the parentheses, it's this without the exponent. So it's 1 minus 2.15. All right, so like I said, the hardest part is typing in. So I took a screenshot of a calculator on Google. And so what I did is I went 4.56, make sure you put parentheses here, 1 minus 2.15 to the 10th power, close parentheses, divide, and then you have to actually have parentheses here. So what I would probably do is actually put parentheses in my formula to remember that when I'm typing. So you always need parentheses for this top section, and you always need parentheses for this bottom section. You will get a wrong answer if you forget one of those sets of parentheses. So divided by 1 minus 2.15, and this is what my calculator output. So I just rounded to the nearest hundredth as the directions say. All right, let's go try it, but it's going to get a little bit trickier as we go. All right, here's the next one. Use the formula to find the sum of the first 10 terms of the sequence. So every single time I'm writing down my formula and what I need. If I can fill in these three, I'm good to go. So every time I start a problem, I write down my variables. So let's see, I know my first term, it's 5. Okay. Let's do the next easy one, sum. It's asking for 10 terms, that's your n, number of terms is 10. The ratio is about as hard as it gets. The ratio in here is, remember, what do we do from one term to get to the next? From this term to get to the next. So sometimes I draw the little arrows in there if you need. How do you get from 5 to 10, 10 to 20? Well, you multiply by 2. All right, so if that makes sense, let's plug it in the formula. So we're finding the sum of the first 10 digits. A sub 1 is 5. And then we're going to go 1 minus 2 to the 10th over, parentheses, 1 minus 2. Same exact thing, no exponent, no first term. So it's a nice, easy way to remember the formula if you need that. You got a little in front, little in back, same in the middle. I kind of like to see it that way. So let's see, I did it exactly like this. You just type it in your calculator where I put parentheses here. You don't need anything extra, and you get 5,115. All right, remember to pause the video as needed. Next one. Same exact example. Use the formula to find the sum of 8 terms of this sequence. So let's see, let's answer the easy questions. First term, 2/3. Number of terms, 8. The ratio, it's kind of tricky. So we talked about this the other day. The best way to do this is to take one term and divide by the previous term, because that's the opposite of how do you get from the first to the second. So to go backwards, we're going to divide. So I have that set up over here. We're going to take 1/3 divided by 2/3. You could have also done 1/6 divided by 1/3. This will give me my ratio. So if you do this, 1 divided by 2 is 0.5, 3 divided by 3 is 1, so 0.5, aka I wrote it as fancy way 1/2. Okay. So you can try to make sense of it if you'd like. If I go from, say, the second to the third term, do I multiply by 1/2 to get from here to here? Yeah, because you multiply the ones, you multiply 3 times 2. Same thing here. 1/2 of 1/6 is, in fact, 1/12. So it makes sense. All right, let's plug it in. So we're finding the sum of the first 8 terms. The first term is 2/3. Then 1 minus, now I think it's easier to type 0.5 in my calculator, so that's what I did. Oh, just kidding, I wrote 1/2. But if I were you, I'd write 0.5. Otherwise, notice I did in fact put these parentheses here, because to raise the whole 1/2 to the 8th power, you have to put parentheses around that. Like I said, 0.5 would be better, but if there's an instance where you can't do the decimal, you do need to put parentheses around here, otherwise only the second part gets raised to the 8th power instead of both the numbers. And then this is the same on bottom, 1 minus 1/2. Okay. Type it in your calculator and you get 1.328. You can double check me if you're not sure. All right, here's another one. Same exact thing. We're finding 12 terms. Let's start with that this time. 12. Right there, it tells us. The first term is 27. The ratio, okay, a little bit trickier this time, but I'm going to try to do it in my head. If I go, how do you get from 27 to -9? Go backwards. -9 over 27, or 3 over -9. So they're getting smaller, so it makes sense, and my answer is going to be a fraction. 9 over 27 or 3 over 9 is a third. But notice they're alternating, so it's a negative, because you're either dividing by a negative by a positive or positive divided by a negative. All right, plug it in. S sub 12, 27, oopsies, 27, 1 minus negative a third. Notice my parentheses. This would be a good example compared to the last one. Unless you want to do the decimal, which isn't very nice, I would go minus the negative. Now you can't go right to plus because this is going to be raised to a power. So do it exactly like it looks. Put negative 1/3 in, parentheses around the whole thing, then raise to the 12th power. And on the bottom, you could do changing this to plus right away, or I just personally typed it in minus a negative 1/3. All right, why don't you try this and tell me if you get the same answer? I got 20.25. Hopefully that is correct. All right, let's try some more. Ooh, sigma. Okay, sweet. So this is really the other half of the lesson here. So it's no different. We're still doing the sum, and the reason I'm doing sum is because I have the sigma notation. Sigma means sum. And I can tell this is a geometric because there's a times in the operation, or in the equation. So if there's a plus here, it would be on arithmetic sequence. All right, so what I thought might be best is if I actually found a couple terms. In fact, I wrote it out so I could find all 5 because I'm going from 1 to 5. You don't have to do this. I'll show you a little bit shorter way on the next problem. So I just plugged in 1 first. That's the first term. The second term is plugging in 2, plugging in 3, all the way up to 5. So I wrote it all out. You certainly don't have to do this, but let's just kind of get a grasp of it. So the first term is 6. The second term is 18. And that's actually as much as I need, because that gives me a bunch of things. I know my first term is 6. I know from this 1 through 5 is 5 numbers. Okay. And the ratio, I think, is actually pretty obvious here. How do you get from 6 to 18? Well, you multiply by 3. Or you could actually see it right here too, because whenever you have the explicit formula, you have a number raised to an exponent. The difference is going to be that exponent, or excuse me, the base of the exponential portion. Okay. Notice the first term is not the number after the side, at least in this equation, so I would in fact calculate the first one every time. So like I said, I'll give you a shortcut. If you calculate the first 2, I promise that's enough. Okay, every single time if you do 2. So the ratio would be 3. Sorry, long explanation on that. All right, let's do this quickly. S sub 5 is 6 times 1 minus 3 to the 5th over 1 minus 3. Those are nice answers. All right, and I get 726. All right, let's try another sigma. So like I said, if you can just write out the first 2 terms, you will be good every time. So the first term is going to be 100 times 1/2 to the start here. I know it's a weird one. We'll talk about this. To the 3rd power. The second term would be 100 times 1/2 to the next term, which would be 4th. Oops, drag down. Follow my own directions. There we go. So the first term, 100 times 1/2, 0.5 to the 3rd, 100 times 0.5 to the 4th. Let's actually calculate those. Just typed them in my calculator, and these were the 2 numbers I got. So first 2 terms are enough to get me everywhere I need. So the first term is 12.5. The ratio, well, okay, let's deal with that in a second. Let's talk about the number. It might be a little easier this time. How many digits are there from 3 to 7? So this is a nice easy one where I can just count them out. So 3, 4, 5, 6, 7, that's 5 numbers. So the number of terms is 5. Or you could do the thing we talked about in class where you go 7 minus 3, and then remember there's always a plus 1 on the end. So 7 minus 3 is 4, plus 1 would in fact get me that I'm doing 5 terms. Now the ratio, how do you get from 12.5 to 6.5? Remember we said we take the second term divided by the first, or term divided by the previous. So I wrote that out here, and I took 6.25 divided by 12.5. And if you type that in, that is a 1/2 or 0.5. All right, let's plug it in. We're finding the sum of the first 5 digits. Starting at 12.5, there it is. 1 minus 0.5 to the 5th over the same thing here, 1 minus 0.5. Oops, there we go. Okay. Parentheses are good because I use 0.5 instead of a 1/2, so a little less to type in. I got 24.22. Let's do another sigma. All right, so let's see, a couple things. Oh, I know the number of terms pretty easily. If I'm going 1 to 15, that's just 15. Okay. And if I can find the first 2 terms, I'll be good. So the first term is negative 2 to the 1 minus 4. Oh, that's weird. And the second term would be 2 minus 4, just going up by 1 each time. When you type this in your calculator, make sure to put parentheses around here, or just calculate what's 1 minus 4, that's negative 3. 2 minus 4 is negative 2. You do need parentheses around the negative 2 here. And let's see, these are the two digits I got, negative 0.125 and positive 0.25. So my ratio is second divided by first, right there, which is, in fact, negative 2. And the first term was this, negative 0.125. All right, I'm just going to click here. Okay, hopefully everything's okay. I typed everything right. I did, in fact, again, put that parentheses around the negative 2. We talked about this earlier. The negative needs to be raised to the 15th power. You can't go minus makes plus, done. Okay, you could down here, but I just showed my work. So when in doubt, type it exactly like it looks. And I got this answer. All right, I know this goes to slide 15, so I got a couple more. Let's see what I got here. Oh, okay, word problems. This will be good. All right, I will read it to you. In a race competition, there are 25 participants. The prizes are awarded according to the following rule. The first prize is 1,000. The second prize is 3/4 of the first. The third prize is 3/4 of the second, and so on until the 25th prize for the last arriving athlete. How much money do the organizers need to have for the prize fund? All right. So everything is actually in here. There's nothing extra I need to do. So there are 25 participants. That's the number of terms I'm going to add together. Okay. The first prize is 1,000. That's my first number. And my ratio, I guess I should have focused on, the reason I know this is a geometric, besides the fact that it's in this lesson, is because you're multiplying by 3/4. Multiplying by 3/4. Okay, I'm not adding or subtracting, I'm multiplying. So my ratio is in fact 3/4 because each one is 3/4 less, more, however you want to say that. So you got all the numbers, plug it in. Again, fraction, you could do 0.75 if that'd be easier. You wouldn't need parentheses then. And I get, whew, that's a lot of money. $3,996.99. I do believe I have another word problem. Here it is. All right. In an old fable, a commoner who had saved the king's life was told he could ask the king for any just reward. Being a shrewd man, the commoner said, "A simple wish, sire. Place 1 grain of wheat on the first square of the chessboard, 2 grains on the second, 4 on the third, until you have filled the board. This is all I seek." How many grains was needed to do this? Not really sure why anyone would want grains, but hey, let's go with it. All right, so the first term is just 1. 1 on the first. So first is 1. Okay. The ratio. So what's happening? You have this little picture right here. We have 1, 2, 4. For doubling, we'd get 8. So doubling, think about it that way, right? Okay. We're just multiplying by 2. It's 2 times bigger from one square to the next because we're multiplying. And then how many things are we doing? Well, if you look at this chessboard, the whole thing needs to be complete. It is 8 by 8, so that would be a total of 64 squares. Plug it in. I have a feeling this is going to be a very large number. Let's see. Ooh, wow. Let's see that. 1.845, and then your calculator probably says E19, which really stands for times 10 to the 19th. So this is completely pointless, but here it is, written all out. So I took the decimal, which was right here, and I moved it over 19 times. I literally don't even know what number that is. This is millions, this is billions, this is trillions. After that, I got nothing. So if you know that, way to go, because that's a bigger number than I know. All right. Oh, that's it. I thought I had one more slide. So go ahead and do homework number 6, and good luck, students.